Piecewise functions. In this video, you'll learn how to make sense of the roles of a piecewise function when they are written in function notation. You'll also learn how to explain what they mean in the situation represented. So let's look at piecewise functions. A piecewise function is a function defined by different roles over different intervals of the domain. To graph a piecewise function, we'll start by identifying the boundary points where the function roles change. Then we'll use open circles for values not included and closed circles for included values. We'll graph each piece separately, ensuring continuity when necessary. So let's practice graphing a piecewise function. We'll start with the first rule where it says the function is x for values between 0 and 3. So we're talking about the x values between 0 and 3. Our function says it's just x. So we can use the equation y equals x to plot these points. So if x is 0, then y is also 0. And if x is 1, then y is also 1. If x is 2, then y is also 2. And if x is 3, then y is also 3. We can see in our rule that 3 is not included because the inequality symbol doesn't have the equal sign under it. So we'll use an open dot for this one since it's not included. We'll finish by drawing a line to connect the dots. Now let's look at our second rule. It says that our function will be x minus 4 for x values between 3.5 and 5. So we're only concerned with this section of the x-axis on our graph. The function says that it will be x minus 4. So to find y, we'll just take the x value we have and subtract 4. So if we have 3.5 and we subtract 4, we'll have negative 0.5. And if we plug 4 in, then we'll get 0 for y. And if we plug 5 in, then we'll get 1 for y. We can see that both of our inequality symbols have the equal sign, so both of our points will be included. Now we'll just draw the line to connect all of them. Let's look at another example. P is a function that gives the cost of mailing a letter from the United States to Mexico in 2023 based on the weight of the letter in ounces, W. So a letter weighing 1.5 ounces would be $2.27, because 1.5 ounces falls between this range, which says $2.27, and a letter weighing 3 ounces would be $3, because this falls in this range where it says it would be $3 for that weight. Let's graph this function so we can see the values a little clearer. Let's start with our first rule that says the value will be $1.50 for weights between 0 and 1. So we'll look at this section on the x-axis between 0 and 1, and we'll draw a straight line across representing $1.50 for all of those values. We can see the first inequality symbol doesn't have an equal sign, so we'll represent this with an open dot. This symbol does have an equal sign, so this value is included. So we'll put a closed dot for this one. Now let's look at our next rule. So we're focused on x values between 1 and 2. So we'll draw a straight line in those values at $2.27, and we have an open dot for 1 because that's not included, but we have a closed dot on 2 since that value is included. Let's go to our next section. So the price will be $3 for weights between 2 and 3. So we'll graph on this section between 2 and 3. We'll put a straight line across at $3. We'll leave our value of 2 open and our value of 3 closed, since that's what the inequality symbols tell us to do. Our last section says the price will be $3.76 for weights between 3 and 3.5 ounces. So we'll be graphing in this section. So we'll put our line at $3.76. 3 will not be included, but 3.5 will be. So now we finished our graph for this piecewise function. Let's look at another one. A parking garage charges $5 for the first hour, $10 for up to 2 hours, and $12 for more than 2 hours until the end of the day. Let G be the dollar cost for a car parking in the garage at noon for T hours. We're going to create a piecewise function from this problem since different intervals have different values. We can see the parking garage charges $5 for the first hour. So we can represent this as $5 for all T values between 0 and 1. We know that they charge $10 for up to 2 hours. So we can write this as $10 for all values between 1 and 2. And then it'll be $12 for anything more than 2 hours. So we'll write this as $12 for any time over 2. Now that we have a function, we're going to use this to fill out the table. So if we parked for 0 hours, then we would owe $0. If we parked for half an hour, we would use this first function rule, which tells us it would be $5. If we parked for 1 hour, we would still use our first rule. If we parked for 1 3/4 hour, which would be 1 hour and 45 minutes, then we would use the second rule. So this would cost us $10. And if we parked for 2 hours, we would use this rule again. So this would also be $10. And then if we parked for 5 hours, we would use our last rule. So this would be $12 to park for 5 hours. Now let's graph this piecewise function. We'll start with our first rule that says it's $5 for all hours between 0 and 1. So we'll draw a line on $5 between 0 and 1. We'll have an open dot on 0 and a closed dot on 1. Now we'll look at our second rule that says it'll be $10 for hours between 1 and 2. So we'll put a straight line across $10 between 1 and 2. We'll have an open dot on 1 and a closed dot on 2. The last function rule says that it'll be $12 for all values greater than 2. So we'll draw a line on 12 for all values that are greater than 2. We only have one boundary point on this one, and we'll have an open circle since the values are greater than 2 and not equal to 2. Now we can also see that this presents a function because every x value has exactly one y output. Now let's decide if this piecewise graph is a function. We can see at the value of x equals 2, it has two outputs at 1 and 7. And the x value of 6 also has two outputs at 3 and 7. So this is not a function because it doesn't have exactly one output for every input. We're going to use this new graph to answer the following questions. Our first question asks, what is g of 1? We'll go to where x is equal to 1 and see where it hits our piecewise graph. It hits twice, one at an open circle and one at a closed circle. We only care about the values that are closed. Since the closed dot is at 4, g of 1 is equal to 4. The next question says, what is g of 12? So we'll go to where x is 12 and see where it hits our graph. We can see that it only hits once on the line where y is equal to 8. So that tells us g of 12 must be 8. Now we're going to decide what x values is g of x equal to negative 6. This time we're looking at the y values, so we'll go to where y is equal to negative 6 and see what x values have a function there. We can see that it includes all x values between negative 8 and negative 1. Negative 1 has an open circle though, so we'll make sure not to put an equal sign under that inequality. Now let's look at the domain of this function. The domain is the set of all input values or x values in our graph, so we'll look to see what x values are included. We can see that the smallest x value is negative 15. Our largest x value happens at positive 15. All of the x values in between negative 15 and 15 are included because they are all on the graph. So our domain is all values of x between negative 15 and positive 15. Notice that 15 had an open circle, so that's why our inequality symbol doesn't have the equal sign underneath it. Now let's recap what we've learned. A piecewise function has different descriptions or rules for different parts of its domain. The graph of a piecewise function is often composed of pieces or segments. The pieces could be connected or disconnected. When disconnected, the graph appears to have breaks or steps.